Yeah, so let's do our agenda. So yeah, Jesper, you're going to do a kind of practice
Spiel.
presentation.
Yeah, exactly. I will show the slides or the presentation I will share on UActic Congress,
Yeah. Okay.
uh, which
You
will take place from 25th to 29th of May this month.
okay? So there's that.
Yeah,
Um,
exactly. I have around 7 minutes for the presentation and then 3 minutes for question and
Great. Okay.
uh,
All right. So we know about that. Thank you very much, Jesper.
yeah.
Um, anyone else?
Yeah, I'd like to talk about London Climate Week.
Yeah. Right. Been trying to keep that free. Well, I have been keeping it free, Herb.
Good.
So, yep. Okay. Now I've come up with some new interactive report pages. So I'd be quite keen to hear feedback. Uh, it's like with all these things, you put a lot of work in, and you think, well, is it going to is it going to move the needle at all? So um, so interactive. Uh, so climate charts. Let's call it that. Do that briefly.
I'm interested to talk about the climate and energy debate.
Yeah. Okay. I saw your email, Robert. Thanks for that. And I thought, fair enough. Let's discuss it this evening. Uh, is that the Mark Mills thing?
Yes. So, but I think it also relates, while you were off fixing your computer,
Yeah.
Herb was telling us a bit about the fossil fuel non-use agreement, a conference that's just happened in Cartagena.
Okay.
At,
Right.
so, like, there are all these issues around, what are the practical strategies on climate and energy.
Yeah. Okay. Yeah. Right. Um, yeah. Okay. So, uh, okay. Talk about climate and energy debate. Yes. Yeah. I mean, one thing Mark Mills said I thought was interesting. He said, the amount of oil per capita hasn't changed much in decades. In fact, slightly less, but it's generating a lot more wealth. But there's a lot more people in the world, so that's why there's more oil getting used. And so anyway, but yeah, let's see what you and others have to say about it as well, Robert, because I haven't got much more to add than that. Um, okay, anything else? We've already taken up 15 minutes. Anything else, folks? If not,
There was something that Ron Bayman put an email in about a new discovery of very small particles in the lower stratosphere, which they
mm,
reckon could influence the models such that they need to adjust the models to take account of it. I don't know if anyone else saw the email from Ron. It was last week, I think.
yeah,
Last week? No, t today.
yeah, so it came today. That was I saw that a few days ago and didn't read. Yes, okay. Didn't really know what to make of it. Well, it'd be the implications, if it's
Yeah, it's
okay.
unclear at the moment, but they
Yeah,
made this discovery that
yeah,
they were unaware of before because the sampling methods they use weren't able to get sample these very, very small particles. I
yeah,
think they were like zero point 0.1 of a micron or something
yeah,
like that.
yeah. Okay.
Anyway, there's
Yeah,
I can just show you the link to the paper which Ron put in his email.
yeah, implications for SAI. I mean, that's the crux of it, really, isn't it? Would there be any implications? Right. Okay. Right. Anything else? Yeah. Okay.
Oh,
Yeah.
was Grace Slater. It's probably, I mean, we put it at the end, but no, I saw the the documentary, Plan C for Civilization, which some people have seen. And it was depressing because to me, it was a forum where they discussed it afterwards, the director and actually had Caldera and some other actual people there. And anyway, it's basically some documentarian embedded himself with two different groups. One was David Keith basically for years, and another was the Make Sunsets guys.
Yeah.
And the upshot of it is that the only two people who are even close to putting any sulfur in the atmosphere have been total failures. That was my conclusion. So they had this panel which included people from that we know which discussed ridiculed the Make Sunsets people, of course. But I mean, because like they're an absurd thing, but they're actually trying to do something. They're actually attempting to put stuff up there. And then Keith, who is now much more conservative, but years ago he was much more. If you read his stuff from years ago, he's much more proactive and gung ho. But anyway, his whole Scopex thing collapsed, and he has no plans to pursue any open air experiment himself. As far as I know, even though he's head of this, he's a billionaire now, and he could fund. He could fund a serious thing. But anyway, I don't know if it's worth talking about or getting reflections from other people. That's all.
All right. Okay. Thank you, Greg. Thank you. All right. Okay. So let's have you, Jesper, please. Let's see your presentation, please. And I need to make sure that you can actually share your screen. Yeah. There you go. Should be able to share your screen now, Jesper. Now, can we interrupt you, Jesper? I might interrupt.
You're muted, Jesper.
You're muted.
You need to unmute, Jesper.
Okay, super.
That's it.
Yeah, so this is the U-Active Congress takes place at the Faroe Island later this month, and I will present as one of the
Faroe Islands. That's really north. That's really north, isn't it? Of kind of Scotland.
Yeah, exactly. And the island is so small, there will be 1,600 participants in Tórshavn, so there will be full accommodation. So this is my project, which is shown here, and the abstract was approved or accepted.
Yeah. Good.
Yeah. And this is my slide. So yeah, this is some images from the Arctic Repair Conference last year, where I participated with the same project, the wind turbine which evaporate water into the atmosphere. And this is a well-known problem that the Earth energy balance is around 1% of the sun's energy. And because of that, the sea level has begun to rise again after 6,000 years of stability. Then it suddenly began to arise again. And according to the Milankovitch cycle, we should enter into a new ice age within some 1,000 years. But because of global warming, it is predicted that the sea level will continue to rise. So we must do something, try to stabilize the global warming and counteract global warming with this climate interventions project. Yeah, this is my proposal of how it could look on a wind turbine, and this is adiabatic evaporation cooling which is well known in greenhouses and similar areas. This is a power breezer from the US, which worked in a similar way where water is evaporated into the air when the air is dry. Hugh Hunt and Southern Cross University and Cambridge have done some trials on the Great Barrier Reef with this cooling by fogging, where Hugh Hunt confirmed that it works on the Great Barrier Reef, and they have some struggle with MCB to work. So this is actually very similar to my proposal in some way. And the overall idea with when we rehydrate the Earth is to reduce the boron ratio in favor of latent heat instead of sensible heat, where the temperature rise. So when we rehydrate the Earth, it will help to increase the reforestation, prevent forest fires, reduce the Earth's mean average temperature, and it will be possible to bring the temperature back as before the industrialization within 50 to 100 years. And we could also stop the ice melting at the poles and stabilize sea level rising, prevent tipping points, and transform desert areas into fertile farmlands, turn sand areas into soil which act as carbon sink. And one of the drawbacks is there's a need for all this equipment and a big water irrigation pipes to be installed in desert areas and something.
Okay, do you want to take a question now, Jesper,
Yeah.
or wait till the end?
That's fine. If someone has...
John Mottcole has a question.
Hey, yeah, on the prior slide, do you own the that image with the ocean and the gigantic clouds coming out the back of the wind turbines? Because that's a beautiful slide, and I've been using it too, and I just don't know where it came from.
I can share the link. It is DTU in Denmark that has taken this image. I do not own the image. It is some phenomena which takes place naturally, mostly in the winter time. I can share the link after my presentation.
Great. Yeah. So you're saying that effect is natural without any additional equipment to put in hydration or other particles. You're saying that's a purely phenomena of the pressure change behind the turbine.
Yeah, exactly. And also some advection radiation fog. I think it is an offshore image. It is very rare phenomena. I can
okay.
only find two times where it has actually taken place at one of the first wind farms in Denmark. So
Okay, but what you're proposing is to actually add water in the image to the right of it.
yeah, exactly. So this phenomena happens much more frequently.
What happens more frequently?
So this phenomena happens more frequently. Of course, to cool the atmosphere. That is what I'm proposing.
Yeah.
Cloud condensation behind the turbine.
Yeah, exactly.
Right.
So additional water mist humidification.
Yeah. So what you're proposing would happen more frequently is you'd add water. Yeah.
Yeah, exactly.
Right.
So instead of it happens once time for each 5 years, it will happen, let's say, 20 times a month or something. When the air is dry and once it makes sense to humidify the air, then the machinery should be activated, or the water system.
And can it use salt water?
Yeah, we can use salt water, or we could clean the water through a desalination plant with reverse osmosis.
If it can use seawater, then it's much cheaper.
Yeah, that's true. it could be seawater if the authority could accept that arrangement, then we can use salt water.
Yeah.
Or
Okay.
the government. Yeah.
Yeah. Okay, please continue.
Yeah. So yeah, this is as the similar poster material as I used at Cambridge. And yeah, it is the Mollius diagram, which is described that the atmosphere can be cooled from 40 degrees centigrade to immediately 22 degrees centigrade once the air is humidified. And it only requires 7.5 gram of water to cool 1,000 gram of water from 40 degrees centigrade to 22 degrees centigrade. And it immediately cooling of 18 degrees because of the humidification. So if this cooling cycle is activated in the early evening time, then I expect the temperature will be lower in the morning compared to if we don't evaporate water into the atmosphere. So the yellow line represents the additional cooling because of this humidification. And during the night, this water will be removed from the air again. So I don't expect this low-hanging fog will trap heat during the night. That is, of course, an experiment that needs to be tested before being able to come up with any conclusion on this cooling arrangement.
Could it be that it makes low clouds? It uses the warm air that it evaporates in the warm air. Sorry, it's making low cloud because low clouds are effective at cooling because they're warm and they radiate heat upwards.
Yeah, exactly.
Maybe we can, let's discuss that. Have a question about that at the end. Yeah, please continue.
Exactly. So yeah, I have collected some data from the weather station in Denmark and have tried to determine how much additional cooling can this concept obtain. And many times it is actually possible also to cool down the ocean water. So let's say we over circulate water that will drop to the ocean again. Then I have calculated the wet bulb temperature to be 4 degrees centigrade. And once the ocean water temperature is 12 degrees centigrade, so in that scenario, it would be possible to cool the ocean water with up to 8 degrees centigrade and only 4.7 degrees centigrade for the air. And sometimes the weather is also that it will only be possible to cool the air and not the ocean water if the wet bulb temperature is higher than the ocean water itself. So one of the advantages of this solution is that it can both cool the atmosphere and the ocean water at the same time if the wet bulb temperature are low. Another thing is that both fresh water and salt water can be used for evaporation cooling.
Yeah.
Yeah.
So
And
the way it cools the ocean, how does it cool the ocean then?
yeah, if water from the ocean is circulated up to the evaporator unit, then if we circulate more water than the air can accumulate, then it will fall down to the ocean again. And I expect the ocean or the water will be cooler than it was before than the
Okay.
ocean itself.
So it goes up in the air, it cools, and then it falls down as cold rain, which cools the ocean.
Yeah, exactly.
The
Or
surface of the ocean, at least.
condensation water. Yeah. So that kind of experiment, it would be very interesting to calculate how much water per hour how many cubic meter of water can this setup cool. Of course, we can try to calculate it, but it also makes sense to measure it during
Yeah.
real experiments.
Yeah.
And yeah, this is just one day, and there could be many other weather scenario or temperatures where it could make sense to determine how much cooling can this evaporation cooling do, both for the air and for the water.
Right.
So that is one of the thing I think makes sense to investigate.
Yeah.
Yeah. And I have also included this kind of equipment just to show that there is already a lot of equipment in operation that use this technology. Evaporative cooling towers use evaporation cooling to reject heat from industrial heating.
Yeah.
Not with the purpose of cooling the atmosphere, but I think if I will try to convince the audience that this kind of setup can be approved, and since there's already many other solutions already in operation, then I think it will be easier to convince them, to show that snow cannons is already in operation. And this is the Mist America 360, a patio cooler at restaurants, also using this evaporation cooling. So yeah, and then there's questions or comments.
Okay, thank you very much.
I think
Yeah.
I have tried to keep it short and not dig into too many details.
Very good. Yeah.
Thank you.
Okay. Do you want to manage the questions? Can you see Robert Chris has his hand up?
Yeah, Robert Chris.
Hi, that's good. Interesting.
Hi.
Jesper, could you just run through exactly how you see the climate change impact of this? Now, I understand that this the phase change and its impact on latent heat, and how this is making the local area cooler. But what I do not understand is how this translates into increased outgoing long-wave radiation at the top of the atmosphere, which is the only way ultimately that the climate system cools.
Yeah, exactly.
So how does this local cooling get translated into increased outgoing long-wave radiation?
Yeah, first and most importantly is that it converts sensible heat into latent heat and thereby reduce the temperature. I can see you had a similar discussion with Rob Delayed earlier last week. And one thing, as I see it, is that this cooling cycle is a endothermic cooling cycle, similar to, there's also some other chemical reaction, exothermic cooling heating cycle, where you have a epoxy glue that generate heat once it hardened. This is the opposite reaction, as I see it. So one thing is that how it rejects energy into space. I think it's when the sun shines naturally, then the temperature increases and the relative humidity is reduced, and that gives the opportunity to cool the atmosphere once we have this situation. And on wet days, or
I think we've lost you. We've lost.
I mean that the cooling is being recycled, so it cools when it's happening, and then that energy is recycled and it warms somewhere else. But it's not actually the energy itself is not actually escaping out of the climate system, because all of the stuff you've described, unless I misunderstood it, is happening quite low down in the troposphere.
yeah,
So there's a big chunk of the atmosphere above what you're doing, and the top of the atmosphere where the radiation is exiting from the system. So it isn't clear to me how that heat loss translates right through the troposphere and the stratosphere and out to space. I just have this sense that what's happening here is you're recycling it, and locally it's cool. It's good. I mean, listen, I'm not knocking the idea in terms of providing local cooling. I think it's extremely valuable, but I simply don't grasp how this actually reduces the amount of, or rather increases the outgoing long wave radiation at the top of the atmosphere.
Yeah, that's true. But one thing is energy, another thing is the temperature level. So imagine how our own body temperature is constant regardless of the activity level. So if we are consuming, or if the activity level is 1 kilowatt of energy, then the temperature is still 100 degrees Fahrenheit.
Yeah. So is it more of an adaptation measure? It's not a climate solution that cools the planet, but it doesn't cool, the vast oceans, which is,
I think
70%
still
of
has
the, yeah.
unit because a snow cannon can produce snow if the temperature is 2 degrees centigrade and the air is dry before the evaporation. So it could also generate snow if the air is dry. So this wet bulb cooling, I think it's a very efficient way of cooling, actually.
So does
Yeah.
it,
Well, I think the critical point here, though, just want to get this absolutely clear, it is local cooling. It's not cooling the planetary climate system.
is that,
Mm,
is that right, Jesper? It's cooling the local area, which is good.
yeah,
Well worth having, like an adaptation measure, so people don't die, but it doesn't make more energy leave the planet.
that is what makes sense to test, actually. I think, yeah.
So that you're not sure. That's why you want to do some tests. It might be possible, but you couldn't explain why necessarily.
I think it makes sense to rehydrate the Earth, to convert the sun's energy into latent heat energy, um, and also another thing is that at lower temperature the atmosphere can hold less water vapor than dry areas. So one of the reasons that the atmosphere can hold more water vapor is that the hot areas.
Yeah.
And another thing is that water vapor is a greenhouse gas, but it's also important to have in mind if the lifetime the water vapor is in the atmosphere is 4 days instead of 8 days, which is the average lifetime, then it will not have the same trapping heat effect as the water vapor that stay in the atmosphere for long periods.
Right. Okay. And you have some more questions. There's John McDonald and Alf, and lots of questions from people.
Go ahead with.
I think let's have John McDonald.
Okay. Hi, Jasper. Yeah, it's good to see you again. We've chatted about this before as well, and just a couple of questions about delivery. You're showing at the top of the nacelle, the cannon up there. Are you thinking of retrofit to existing turbines or initial fit out? Because the way I've looked at it, I've looked at it more from a retrofit to existing turbines to use the waste energy at night to power conventional MCB. But I think it could be easier to do it from the bottom of the tower where you can access it than to get heavy loads up to the top there to actually get the equipment up to the top. But have you thought about retrofit or new builds more?
Yeah, I think it would be possible to retrofit the evaporator unit, maybe a smaller evaporator unit on existing wind turbines. But of course, I think the flagship of the solution must be a solution where it has been designed from the beginning on new wind turbines. I see some problems if the evaporator unit should be mounted on existing nacelle units. There is some service heads on standard wind turbines here. So I think maybe the exact location would be a bit different. Maybe on the side, one on each side, that could be a setup.
Yeah, but just a practical aspect down the track. But yeah, good to see what you're doing. Great.
Yeah. Thank you.
Alf.
It just seems to me, addressing Robert Chris's question, that this could potentially cool the planet because, and I may have the meteorology of this or the atmospherics of this all wrong, but water vapor is lighter, warmer than the air around it, so it rises. So could it not potentially rise? As I understand it, could rise as high as 5 kilometers in the troposphere, where there'd be a whole lot less greenhouse gas above it, and so the latent heat would, as it condenses, that's a lot of energy that's given off into space. I might have that all wrong, but that seems to me how it might work.
That's true. Actually, the strange thing is that cloud close to the land is colder, the temperature inside fog is lower than outside, but higher up in the atmosphere, the temperature inside clouds is warmer than the surroundings. So a pilot told me that. Yeah, a lot of heat transfer takes place in the atmosphere.
It would have to do with the condensation giving, as you say, exothermic,
Yeah.
and that heat would go into space.
On that calculation. That calculation is fairly simple. A square kilometer of cloud that increases the albedo of the ocean by 0.5, taking it, let's say, from one number to another number with a differential of 0.5 over the ocean below it, has a certain amount of energy in clear skies that will then leave the top of the atmosphere as reflection, given the incident angle of the sun. So it's a fairly simple calculation, and if you could state a certain amount of energy leaving the atmosphere per gallon of water or cubic meter of water or something that you're pumping out, you could get a cooling return on investment calculation, which I think will be important to interest people.
Right. Isn't this the same as marine cloud brightening at root?
Similar, but if it's using pure water, then it's not creating the.
Oh, don't use pure water. Use salt water. Use submicron sea spray. Then obviously we're going to create cloud condensation nuclei. Obviously, it can have a cooling effect to the extent it provides marine cloud brightening.
Yeah, exactly. Yeah, so thank you, Jonathan. Yeah, I should include a slide with return of investment of sure, and then also this albedo cooling. I have tried to do some initial calculation on another pitch material I could include in maybe delete one of the slides and then include the albedo cooling also. Yeah, that makes sense.
That's what people want to know, Jesper. They want
Yeah.
to know what's the cost, what's the benefit.
Exactly.
It's a nice idea, but if it's unaffordable, then it's a non-starter. Did you have another question, Brian? You still have your hand up.
Oh, just mainly to make the observation that seawater is much cheaper than fresh water. Submicron sea spray is well established. These systems are offshore and they can be producing submicron sea spray, which is going to be really effective at strengthening the extent, duration, and brightness of the green cloud layer. So it can definitely cool.
Yeah, great.
Yeah.
Thanks. And Franz.
Yeah, Franz.
You need to unmute, Franz. Unmute. You must hit unmute.
I think Jesper should also think to the if he gets more water in the atmosphere, at last it goes also up to the stratosphere, and more water in the stratosphere can make also more clouds. There are these high stratospheric clouds, and this could is like a SAI effect. The other effect is if you have more water in the upper stratosphere, you will lose water as H2, which is going into space. This could also, because radiation, the shortwave radiation,
Yeah.
destructs water molecules and produce H2,
Yeah.
which is going into space.
Yeah. But water doesn't get into the stratosphere much, Franz. The stratosphere is very dry because it gets frozen before it reaches the stratosphere.
But if you have clouds there, you have not every time clouds there in the stratosphere. They are rather seldom.
Exactly.
But by his effect, he has more water in the stratosphere.
But he only puts water vapor in the air very low on the troposphere.
You know, we are losing every day water as hydrogen in the
from the stratosphere.
From the stratosphere, and you don't condense all water which is coming from below. There will also be every time be a part of water which leaves as hydrogen.
Right. I mean, enormous amounts. That's right. Okay. I mean, the water does get into the stratosphere because methane gets in the stratosphere, and it oxidizes to make water.
But water goes out also there. It depends on the vapor pressure.
Yeah. Okay. John, did you have another question?
Yeah, just to add a comment. Of course, we can do ocean whitening using the surplus energy from wind turbines as well, directly to the ocean surface with albedo, using nanobubbles and even using the energy from the turbine to extract biosurfactants to extend the life of the nanobubbles on the ocean surface. So that's, I mean, together with the MCB, that's an easy thing to add on to and probably easy to retrofit to a wind turbine.
Mm-hmm. Right. Okay, I think we better move on. I would just say yes, but try not to just read from the slides. That's a presentation 101. Talk about, put the slide up and then talk around the slide. Yeah, if you just read anyone who can see your slide can read it themselves.
Yeah, that's true. Yeah. So thank you for the advice, and thank you for the time to share.
Well, thank you for the presentation, Jesper. Let's see where it goes. It's very interesting. A lot of interest in that. Okay, let's move on. Thank you, Jesper. That's great. So let's come back to this.
I think I was next. I see you moved me down.
Well, we tend to do the techie things. All right, go on then.
Yeah, I mean, it won't be long.
Yes, please.
Yeah, won't be.
Yep.
Yeah. So I've last year I moderated a panel for MIR at London Climate Week, and I'm going this year. I'm organizing a panel with Sumitra Das there that we haven't figured out yet. But I'm wondering, since I'm already going to be there, I'd like to try to work with one of you or someone else to organize another panel where we can talk about the things that interest us, which never get discussed at any climate week, almost never get discussed. So that's really my question. Is anybody interested in working with me, particularly if you're in or around London, to see if we can find a venue and figure out a panel and make something happen? That's really all I want to sort of throw out there and find a venue. I know I reached out to you, Robert, Chris, and I'm planning on reaching out to you again to see if you're around or interested. It's June 20th to June 28th, and they haven't really put the agenda up yet or the application. The last time I checked, there is a orientation meeting on this Wednesday of London Climate Week, where they're going to provide some of those details. So that's really all I had.
Okay. I put my hand up. I'm not in London
Good.
anymore, but I get to London on the train. So
Where are you now, Clive?
near Southampton.
Oh,
Yeah,
okay.
I can
All
actually
right.
I can actually walk to the beach from here.
Oh,
Uh, yeah,
anybody else interested? If you are, if just email me if you'd like to, because I'd really like to make this happen.
yeah.
Yeah,
Okay.
I'll email you, Herb, and see what we can do. Actually, I will be away immediately following this. I'm in Paris for 4 days, arriving back on the day before Climate Week starts.
Oh,
So,
good. Okay.
yeah.
All right. Right. And anyone else,
So
please,
just
UK.
whilst we're on this, Herb, did you find a venue for the thing with Sumatra?
Well, I haven't nailed it down, but I got a tip from Barbara Sneath of Mere that there's a community sort of social service agency with some decent digs just north of King's Cross, I think, where I couldn't believe how inexpensive it was. It was like 60 pounds an hour to rent a room for up to 50 people, something like that.
Oh,
So, I
right.
mean, there may be others, but that's one real possibility.
Yeah, because I asked you if you could let me have the topic of Sumitra's presentation so that I could have a word with some people, and you never got back to me. So if you could let me
Yeah,
know what.
and the reason is because we're going to talk tonight about a topic we haven't set it up
Oh,
yet because
right, okay.
he wasn't going to do it, and then I sort of twisted his arm to do it, and he said, "All right, let's make it happen." So I haven't forgotten about you in that regard.
Okay, fine.
One other just quick thing, and then I'll let other folks go. Yeah, there's a really interesting 2-day conference next week at University of Chicago that David Keith is organizing with almost, everybody in the field there, and I hope to go, and a couple other people I know are going. And anyway, I don't know well, Chris, I don't know if anybody else is from the United States other than Ron here that I see who might be interested in going as well. But it's really should be a really very productive conference.
Is
Anyway,
there a
I'll
name?
stop there.
Is there a name to that conference?
It's organized by the Climate Systems Engineering Program at the University of Chicago. I don't know if it has a name per se, and that's right. Sorry, I forgot about you, the California contingent. But anyway, I
That's
mean,
fine.
it's
I,
got
I I can look up his organization. Yeah.
yeah, I mean, it's got people like let's see, Dakota Gruner, the CEO of Stardust, Doug McMartin, Keith himself, Ken Caldera, Pascal Lamy, who organized the Climate Overshoot Commission, the former foreign minister of Pakistan, and on and on and on. So it's could be really interesting. That's
Thanks.
it for me.
Okay. All right. Are we done then? Thank you very much, Herb. Okay. Um, right. Anything else to say about small particles, uh, Chris? You're muted, Chris. You're muted. I'm clicking unmute.
Linked. Yeah.
Yeah.
I can show the article that Ron Bayman provided link to it today in the HPAC news, HPAC email chain. And
Right.
so, are you ready?
Yeah.
Okay. Yep. So, yeah, this is the article. It was in the 23rd of April issue of Science. And the particles got a mean diameter of 0.11 microns from 0.03 to 0.11. So quite very small particles, submicron sized particles. And it's something that they think that may have effects that the climate models don't take into account, which is why I think Ron flagged it up in his email.
Okay.
Yeah,
So
they say at the end of the article there, global chemistry climate models fails to replicate the characteristics of these particles, suggesting the model improvements are necessary for accurate assessment of any proposed geoengineering effects. Anyway, just for information there.
great. So I think
If you want to find the article, just find Ron's email which was earlier today.
Yeah.
In the HPAC email chain, and you can find it there.
Right. Thank you. I mean, basically, we look forward to hearing from people like David Keith and Doug McMartin, I guess, what difference they think that might make.
Now, Ron's back on now, if he might want to say something as well.
Yeah. Can you guys hear me?
Yep.
Yeah. Oh, thank you.
I think you're muted, Ron.
I can hear Ron fine.
I'm in this crappy.
I can hear you fine, Ron.
Okay.
Yeah.
Let me just continue. So the article is indeed, I agree with Chris. It's quite interesting. No surprise there. The article does state that these are hitherto undiscovered particles in the stratosphere, and that the implications none of the models take this into account. They do have, many. The article still strongly suggests that this is going to affect. Taking this into account should have impacts on SAI modeling. On what we think the various impacts are. So it's quite important and quite interesting. That's. I mean, it doesn't really go into how exactly.
Yeah.
So
the other thing that was interesting, Ron, is said there was quite a lot of them. Large proportion were organic particles, not inorganic, which was something that perhaps people hadn't thought of before.
Right.
As your diagram implies, that we can add material to thunderheads, and it'll take it up to the stratosphere for us. Is that true? You're muted.
We're not hearing you, Ron. You're muted.
I did not put up a diagram. I don't know what.
That's your diagram, John.
Right now, it's the background of my profile box.
Yeah,
that's the diagram from your paper, right?
Well, it's not my paper, but the paper itself, you mean, is in there.
Okay.
Yeah. The paper is quite technical. I mean, I sort of. I'm hoping Mike and other folks will go through this, but I don't know that we can read.
I think we lost you there.
Yeah, we've lost Ron. Yeah. So let's just say that Franz has been talking about black carbon in the stratosphere for a long time.
So anyway, thank you, John. Yeah.
Okay. Franz has been talking about black carbon particles in the stratosphere for a long time because they get lofted up. They get warm. They get warmed up because they're black. They warm up in the sun, and they just rise up. And they're very, very small. They warm up the air around them, so that warm air rises. And they loft up. they absorb chemicals and other these chlorofluorocarbons and stuff like that, and all kinds of other things. It gets absorbed because we use black carbon in our filters, because it absorbs stuff, and so it's the same stuff. It absorbs chemicals from the air and takes them up into the stratosphere. So there's a certain chemistry that Franz, but you've been talking about it for a long time, haven't you, Franz? Black carbon going into the stratosphere,
yes,
then it comes down into the polar. Yeah,
especially during wildfires and so on. When you produce lots of soot and also organics, and smoke contains lots of organics.
Yeah.
So the article these particles are smaller, are much smaller. They don't they talk about, I think, carbon and other. You got to go into the article, but I think the issue may be more complex, organic, or something like that. But they acknowledge that those
run on the way up from the troposphere to the stratosphere, there's a lot of oxidation also. And so the particles may become smaller because they go to CO2.
Yeah. Yeah. Anyway, it's all speculation right now, isn't it?
So let me just read from the paper. Yeah, the paper in our measurements show two distinct sources for the small particle mode. In older stratospheric air, they are sulfuric acid with metals from meteors. In younger stratospheric air, influenced by the troposphere, the small particle mode is mostly tropospheric particles with high organic content, which will affect their reactivity with gas phase species. So they already, these, but yeah, maybe that was the wrong one to read. But they do acknowledge that there are existing, there have been detected all kinds of existing particles that have organic content as well. It's just these are much smaller than the ones in the detected. So it's a whole other.
It's interesting which kind of organics are there they are built from.
Yeah. We're going to need to look at the paper, I think.
Yeah.
Okay, we've got 20 minutes left. A little bit more than 20. We've got 23 minutes left. And so we want to talk about climate and energy. And I wanted to put these charts up now. So if you don't mind, I'm going to do that. And so I do need to share my screen and come back to this. And so I sent this to Robert Chris, who kindly gave me a lot of detailed answers. I fixed some of it, Robert. Yeah. And so this is it. It's just it comes up on your web browser. I just sent Robert a link. This link here. Just click on the link and it brings it up here, and it brings it up like this. So. This is based on Jim Hansen. So, people like Alan Gadian, I don't know if he's saying might even go up 8 degrees in a short space of time. And then we get all these wildly different projections. But Jim Hansen had a graph that actually, if I'm brutally honest, I just looked at the graph and it was the temperature had changed by 0.4, and so he specified 0.41, and I looked at the graph to get these dates here, these years. So from 2014 to 2026, the temperature went up by 0.41. So that's no, more than that rather. So it works because it's 0.41 per decade. So this is it. So 0.41 per decade if it keeps going up at the same. So this is just an example temperature rise, and because it's a bit confusing, this Bill Gates and people saying, "Oh, it's not such a problem." I don't understand. People here might need to inform me why Bill Gates is all of a sudden not too bothered about the climate. Anyway, so I put in on these. This is, you could call it AI slop, but I think it's not worthless stuff. For each temperature. So anyone, by the way, anyone can, if I put this in the chat, anyone can look at this. This is the whole point. Anyone can look at it. So if I go to the chat, put that in, anyone can click on that and it should bring up exactly the same thing. You can look at it on your own screen. It should work on an iPad as well. Or, a tablet. And it pops up with the effects here, expected effects. And this could be, depending on who you ask and what day it is, people are going to say different things. We've seen all this sort of thing before, but a lot of this came from this was the first book I ever read on climate change. It's 6 Degrees by Mark Linus. What happens for each degree? So this is that same, well, it's the intervals. So from 1 to 1.5, this is what basically Google Gemini said. I said, give me the effects for each degree, and then it gave me these intervals, ranges. So 1.5 to 2. I would suggest we all know this kind of stuff. There's AMOC there at the bottom there, tipping point. from 2 to 3. And so the idea is that, to put this out there, I have to pay money basically to make it persistent, so it doesn't, there's no risk of it going away. But it's public, as you can see, it's publicly available. And I think more people should know that what the effects are, because so many people know almost nothing, and there's so much uncertainty. It's very difficult for people to get their head around what's going on and what to expect. So as I said, I put the link in the chat. Anyone can click on this and you can look at it. And so that's the first one. The next one, you said this wasn't clear to you, Robert. This is really just showing. This is a question: how will life on Earth fare in the Anthropocene, which is the current period where we've got climate warming? And I'm showing the Permian extinction happened 250 million years ago. The cause is roughly a 10% global warming. Took between, we don't know how long. It's very hard to know actually how long it's, but they reckon the temperature went up by about 10 degrees. So here's the temperature going up 10 degrees, and I've picked a number in the middle, 40,000 years. And so 40,000 years, 90% of all species went extinct, 10% remain. It was called the Great Dying it is called the Great Dying by geologists. And so if the current speed of warming, 10 degrees centigrade is projected by Jim Hansen. We know this from his Global Warming the Pipeline paper, from his slow peak feedbacks. I mean, 10 degrees from the previous chart, we're going up 5 degrees in about 100 years. So, if it carried on the same, we'd be at 10 degrees in only a sort of couple of 100 years, a bit more, maybe 250 years. So, but Jim Hansen is saying, well, humans will have been got extinct by then, but there are slow feedbacks, and we know this. So 10 degrees in 400 years. That is still 100 times the warming rate than the Permian extinction 250 million years ago. So how many species would adapt to 10 degrees in 400 years? Forests simply cannot regrow in that length of time. And so the soil gets washed, it gets unstable, it gets washed off, it gets into the ocean.
Clive, could I just mention that your chart is not self-explanatory, because the x-axis it measures in K, and it doesn't actually say years.
Yeah, I think I took that off.
So looking at it initially, it's quite obscure, that it's measuring time against temperature.
All right, I should add years to that axis then, to the x-axis. Yeah, okay, thank you, Robert. So I wasn't sure about that. I mean, it's talking about years here, but 10K, 100K years, but yeah. So it needs to be bleeding obvious. I agree. Yeah, okay, thank you for that. Right, so that's that one. So I thought, just to get people, by the way, you can make this big like that, and then you can pick the pages from here. Hover over or tap the colored areas to see advantages. So once again, this is even more. You could say, well, that's just AI slop. But anyway, I got it to list them all out. What are in fact, it asked me a question: do you want to see the lifeboat areas? I thought, okay, let's have a look at those for 3 degrees. So example, 3 degrees centigrade lifeboat territories, Asian Russia, east of the Urals. And so these you could say almost kind of not exactly random, but I did a certain amount of work. Everything can always be improved. Nothing can ever be perfect. I found I couldn't separate Svalbard from Norway, because it's still part of Norway. So it's showing, giving a score: Sweden 9 out of 10, Finland. The only one that gets 10 out of 10 is New Zealand. But parts of, and you can zoom in like this if you hold down Control and use the mouse wheel. Hokkaido. It's showing the various benefits, and then Northern Canada. I was surprised that the UK, especially Scotland, is quite good. So that's that one, and then you've seen these before. So this is so, people, I don't know how many times I've said this, say, no, you cannot do any cooling. We don't want to do any cooling because we don't know the effects. Well, we do know the effects because it's been going on for so long. This is really just a chart to make the point. Human cooling has been going on for hundreds since 1850 at least, and it's been getting less. And this is why the overall warming influence has been rising so rapidly because of the lack of cooling. If you want to add natural, if you want to see how the whole thing works, this is the natural forcing, and that's the overall if you include everything. And then I think you've seen this other one. I do wonder if people are clear about the way this works. This chart shows data at increasing levels of detail as you go down here. So there's zero detail. This is just everything added together. If you come down here, it starts to separate them out. But then we have to have all the greenhouse gas. We have to have all the warming and cooling influences, so we can put them all in here. Just click these top level selections. We get absolutely everything here. So this is the overall warming and forcing, warming or cooling influence. It's cooling if it goes below the line. Otherwise, it's warming if it goes up. The higher it goes, the higher the warming influence, so it's a climate forcing. I think you can call it a warming or cooling influence. As we come down here, it starts to separate them out. So this separates cooling from the warming influence, but we're still including natural. You could take the natural out and see what it's like without the natural. So this is very, very flexible. You can see how the whole thing works, the whole climate system in terms of warming and cooling influences. They're called radiative forcings because they're the perturbations that change the system, and it's been changing over time. As we know, put the volcanoes in there as well. And so one of the things that surprised me just once again is when you look at take out the natural because it confuses the issue and take out the cooling. This is the influence from CO2, which gets most of the media attention. We must reduce fossil fuel emissions. But what about all these other gases that produce a warming influence? And what are they? Well, if you want to find out, you can go into this thing, take off the CO2. Okay, it's contrails. Well, we can't really see, so we'll need to come down to the detailed level. And these are my own categories: fast oxidable and slow oxidable, because these gases oxidize in the atmosphere because we have oxygen in our atmosphere. Some of them take a long time. Some of them go away within a couple of decades. Methane and contrails are very small. Sometimes they get a lot of media attention, but it's very small compared to these others. So let's take them off. Contrails. Let's see what these fast oxidable ones that we can come down to find now. So there's methane, but then tropospheric ozone is almost never mentioned, but it's nearly the same as methane. Okay, and so here are the others, quite small ones by comparison. Soot on snow, but there's a lot of uncertainty. So there's error bars here to show some idea of uncertainty, or to at least remind us that there's uncertainty in those numbers. And then the last chart is, once again, Franz pointed this out to me at least a year ago, maybe a couple of years ago, that during the pandemic, the rate of methane rise increased. And then since the pandemic, it's flattened off again. So that's, it's not, correlation isn't, what is it?
Causation.
Isn't what?
Causation.
Causation, thank you. Correlation doesn't necessarily causation. But there've been several papers saying that one of the, again, people who love cuddly solutions wouldn't necessarily like this because it's a form of pollution. But it's also, so NOx is the nitrogen oxides, NO and NO2, and they're also produced by lightning, so it occurs naturally as well. But it also comes from transportation, shipping, aircraft. So we should put this stuff into the air, and it reacts with methane. It speeds up the oxidation of methane, so methane gets destroyed that much quicker where there's NOx about. But it's complex. It's not a simple thing because it involves tropospheric ozone as well. But anyway, I thought I should put this up. But what I really want to do is for this thing to be accessible. So very helpful, actually. Put years on that axis. To say something rather than just doom and gloom, that this is a sort of very small kind of thing that people should be looking at because more people talking about methane and very rarely NOx gets mentioned. But this is all small stuff. The big stuff is what we talk about, solar radiation management. Something else about risks. It's very hard to say anything about fossil fuels, going away with any sort of authority. But to say something about SRM, I just keep coming back to the same thing Alan Gadian said to us in his presentation a year or so ago when he said marine cloud brightening done to extreme could cause another ice age. So that is the sort of thing that is the intervention that could counteract these. And even he is now saying, well, it's getting close to even that. Even the strength of marine cloud brightening is getting to the point now that because there's so much feedback in the system, that's going to have a hard time, slowing down, halting the warming and cooling the planet down again. So we're running out of time, but people need to know about SRM. So any thoughts, anyone, about any other thoughts about what could be added as an interactive chart to promote SRM, make it seem like something that ought to be done? Or are you just completely stunned?
Could you do anything on ocean brightening?
I could mention that, ocean brightening. Yeah. Be good to have something else other than just SRM.
Clive, as Greg
Yeah.
Slater, I did just try it. It works out on my computer fine. Thank you for the
Good.
update.
Good.
I
Excellent.
appreciate any visualization stuff. I appreciate, even though sometimes it takes me a while to understand them. But I always appreciate interactive visualizations. The only thing I was wondering, a comment I had was, there's several people working on various visualizations of various parts of the issues. And of course, Bruce Parker has his thing, and Robert Chris has his. I just wonder if there's any way to incorporate some of that predictive power. You're giving the sort of the accumulated material and what the effect. Anyway, that's the only thing.
I thought of that as well, Greg. Thanks for that. Yeah, I thought of that as well. I actually had a look at your spreadsheet, Robert Chris. I had a look at that. I found it. I thought I'm going to need a lot longer to try and remember what it does. This is complex. There's a lot to think about there, and I'd have to simplify it a lot. But yeah, so predictive. Thank you, Greg. Yeah, I'll keep that in mind. Yeah.
So Clive, just to be clear, what were you saying was complex, needed a lot of thought?
I know even that was meant to be a simplification. Your Excel spreadsheet graphs that start here and the peak comes then and that sort of thing, or we end fossil fuels at this date and that date. I'd want to have it so that people could just click and it change, and it to have about 2 or 3 scenarios, and they just click this scenario, that scenario, and it would just show different scenarios.
But you could do that. That would be very easy to set up. If you wanted to run it, if you just wanted to run it automatically, with set scenarios, that would be dead easy to do.
Yeah. And then to get it online so that it's just part of a thing that they don't have to download Excel. They could just click and it comes up on their phone. Yeah. This, by the way, I tried it on my phone. It didn't. Yeah.
You might need to know that I've been invited on Thursday this week to present WTF, my model, to a class of students at Cambridge University.
Excellent. So, congratulations.
you and Sean have got a special climate change course going, which they've introduced for the first time, and they invited me to participate at the beginning of it. And the speaker following me is Dan Schrag.
Okay, it rings a bell. Okay, thanks. We're running out of time, folks. Bruce, please.
Just a real quick comment, something which I hadn't realized till recently. Methane is, you put a methane in tropospheric ozone. Those two are interrelated. Methane causes the tropospheric ozone.
Yeah.
So
right.
if you reduce methane, the tropospheric ozone goes away. So they're not really, tropical it's up there, but it's not separate. It's directly tied to methane.
Yeah.
I don't think people realize that.
Yeah. Yeah, it could be a mention of that. Yeah.
Are you saying, Bruce, if you actually eliminated methane, there would be no stratospheric ozone?
Correct. That's why methane is so powerful. It's kind of because also when you get rid of methane, you get rid of tropospheric ozone. So the two are about the same, about one watt per square meter. And you get rid of methane, and so methane has a much stronger impact on the temperature because it also reduces tropospheric ozone.
Yeah.
So tropospheric or stratospheric?
Stratospheric, whatever. Yeah, one of those. I can't keep them all straight.
Yeah. So
tropospheric, I think.
That's right. It's unburned hydrocarbons. There they are.
Yeah, Those two go together. You can almost could combine it as one thing, which says methane and tropospheric ozone to get a better idea of what can be done.
Mm-hmm.
Yeah, it's worth. Yeah, so it's not just methane. It's any hydrocarbon in the atmosphere.
Right.
When it breaks down, it produces ozone, as I understand it. This is why urban smog produces tropospheric. You get a lot of extra ozone. Especially in the sunlight. So it's the sun. It's a complex reaction of sunshine, sunlight on methane and on the existing ozone. Yeah, that makes OH radicals that then attack the methane, which then it's a complex thing that then produces more ozone. So it kind of starts with a little bit and then it generates more ozone. Yeah, Franz.
Clive, in the beginning of your speech, you mentioned the Permian and Permian extinction.
Yeah.
And the temperature rise over, I don't know exactly what you said, 10 million
10,000
years or 10,000.
Yeah.
10,000.
Between 10,000 and 100,000 years.
It could be even shorter if the warming has been induced by these contamination shocks, or one or more contamination shocks, because of the much soot in the stratosphere from these Siberian sub lip.
Yes. Yeah. Yeah.
So
okay.
we don't know exactly, and we had extreme wildfires also, additional to that.
Right. Yeah. Okay.
Because these char is found as a fossil char all over the world at the end of the Permian.
Right.
That means the plants on land could have been wasted away by the cold of the nuclear winter, in no nuclear winter, but similar, and by the wildfires when the sunshine came again.
We could have the same thing, actually, couldn't we? We could have the same thing. We'll be long gone by then, but with massive drought and huge forests that are all dead, huge wildfires. Yeah. Okay, thank you, friends. We've pretty much run out of time, but I did want to give you a chance, Robert Tulip, to talk about this. what you were saying was I put in a link that was half right and half totally wrong, and that ought to be called out. Did you want to say any more about that, Robert, in the last few minutes? You're muted, Robert. Robert Tulip.
We've run out of time, so I'm not going to bother.
Okay. Sorry about that, folks. Yeah. We could carry on email and maybe bring it up next time. But I take your point. I just wanted to say I take your point, Robert. All right, everybody. Thank you for your time.
Thanks very much for hosting.
See you again in a couple of weeks.
Thanks, Clive.
Yeah. All right.
Bye.
Take care.
Thank you.
Bye-bye. Bye.
Bye.
Bye, Ursula.
Bye. Have a good week. 2 weeks.
Thank you.